Okay, so I will be summarizing the power series, and Alex will be summarizing the Taylor series. So essentially, from the power series recap, so how a power series looked is basically the sum of it has he as Tom wrote it as x to the n of a summation of n equals 1 to infinity, and so power series essentially what the difference is instead of it's a sequence of numbers, it's a sequence of polynomials. And so to be able to evaluate this, he drew out a graph of each several terms of the polynomial, several polynomials in the term of the sequence. Yeah, in the sequence, and drew them out to be able to physically see what exactly is happening in the power series. And so by evaluating each x term in the by evaluating um, um, the x terms at separate uh, different x terms for polynomial functions, he was able to basically determine that the for a power series, typically a power series will not be strictly convergent or divergent. There will be different parts of the series that will converge or diverge based on where the limit occurs. And so in his example, when he drew out three different polynomial functions, there's three different functions that show a certain section of the power series, and was able to determine that if a function was greater than uh, um, uh, was greater than one, it would diverge, and less than one, and it would converge. Um, and so from that, he then discussed the flip side, which is the negative. If the functions were negative, I mean, if the x terms were negative, how does that play a role? And so basically, the x terms would um, basically flip back and forth from positive to negative, and so that it so from if, so comparing the x terms of positive, x terms of negative, the same. Essentially, it has the same um, uh, basic idea that less than one will converge and greater than one will diverge, but just in different ways. So in terms of the negative, so if it's less than one, the function will keep flipping back and forth between positive and negative, and until that it eventually does diverge and converge into one specific result. But in terms of it being greater than one, the function essentially just flips to wide that it just ends up converging. I mean, it just ends up diverging. Yeah, that's basically recap on power series.
Okay, so for Taylor's series, Tom wanted us to work through some examples. And hold on, I'm gonna pull up a whiteboard. Here we go. Okay, so basically, can you guys still hear me? Okay, cool. So basically what we want to do, we want to find what, using Taylor, we want to find an approximation for a fourth, or not approximation, we want to find a fourth degree polynomial. So essentially what you have to do is, for when you're looking for the, I think, is it still the Taylor series for that? I think so. Basically you're looking for because we're looking for fourth degree, we're looking for the fourth derivative. So if you're given like a function, whoops, my pen's not working. Interesting. I guess I'm gonna have to do this the old-fashioned way. So if you do this for a function, Then, so basically you'll have it in this form. Um,
Question: what do the C's stand for?
they're the coefficients. So this is just like kind of like a general form for a polynomial that's increasing in.
Shouldn't you have like x to the first for C1?
Probably, yeah. Andy, is that correct? Yeah. Whoops. I think I misput this in my notes, but it's fine. Okay. So, and then obviously, because we're looking for a fourth, we kind of, skip up there. And then we also want to find the n. So obviously at some point, we're going to have c to the n x, not x to the fourth, x to the n. So what you want is for this new, what is it called? I don't remember. You want it to be equal to the fourth derivative of the function. So you basically, if you take the fourth derivative, you want them to be equal up to certain points. And obviously, depending on how hard you work on it, it can be even more equal to the original function. But for a fourth, you take the fourth derivative, which is this, of your original function, and you evaluate it at 0. And then you divide it by 4 factorial. So that's going to be there. And so obviously, yeah, sure.
Where are you getting the factorial from? Like, how did you?
So I didn't fully understand it, but the way I understand it is basically, you have to, well, you'll have for your fourth derivative, it'll end up like 4 times 3 times 2 times 1. Whoops, I missed my pen now. Times c to the 4, which is obviously going to be, and that's going to be equal to your f4 over 0. So you're essentially, so your f4 over 0 is going to have the factorial in it, and so you're just dividing it out, essentially. And so that also, that like works for increasing. So if you want to find the nth derivative, then, or if you want to find it for the nth derivative, then you're gonna, it's like the same general like format. So it's going to be the nth derivative evaluated at 0 divided by n factorial. So yeah.
Could I ask a question?
Yeah.
Where is your 0 coming from?
So you're looking, I guess the way it works is you're looking for it at x equals 0. So yeah, you're just kind of plugging in your 0 for the fourth derivative of f of x. And that's the top of your, like, the general formula.
So could it be like something else if you were trying to approximate at a different point?
Yeah. Okay. It would be something. Yeah, this is approximated at 0. Sorry. Should have made that clear earlier. Okay. Any other questions?
Did we discuss the discussion question that he asked? Or was that? So find the third degree Taylor polynomial for function of cosine of x and the nth degree for cosine of x.
I'm gonna save this. Do you know how to open a new whiteboard?
You can just clear it, or if you still want it, or yeah.
Okay. Okay, yeah, that makes sense. So what are we finding it for?
The third degree for cosine of x, and the nth degree for cosine of x.
Oh, now my pen works. Okay. So I want to find f3. Do you know where it's evaluated at? At 0? Or
It just says find the third degree Taylor polynomial for f of x equals cosine of
Yeah, let's assume
X.
it's evaluated at 0.
yeah, I'm gonna assume it's 0. Okay. And wait, so what's the original equation of cosine of x?
yes.
Okay. So we have to take the third derivative. So the first derivative is gonna be negative sine. And then second derivative is gonna be negative cosine. Third derivative is gonna be sine of x. And then we're gonna want this evaluated at 0. Sine of 0. Is that 1 or is that no?
I want to say 1.
I want
Yeah,
to say
yeah,
1
right.
too, but I might be getting confused.
Is it?
All right,
I
we'll
think-
say 1. Well, because if it's 0, then this whole thing falls apart anyway.
So you can mentally think about what does the sine function look like, or the cosine function? Like what value does it take at x equals
Oh,
0?
right. Okay.
Oh, okay. Yeah.
Yeah.
So
And then also, if it's 0, then our answer is going to be 0, and that would be an unfortunate journey to go on. All right. So for our c to the third, or c sub 3, then we need to have f3 over 0 over 3 factorial, which plugging everything in basically means this is going to be 1 over 3 factorial.
Sorry. So the sine of x evaluated at x equals 0 ends up being 0. It's cosine of
Okay.
x. That's the one.
Oh.
okay.
So
Yeah.
the
Oh, wait,
point
so
is
this
that
is
terms are going to drop out. Yeah.
So this is going to be 0 over 3 factorial?
Yes, the third term in the third degree Taylor polynomial for cosine of x should be 0.
Okay. Cool.
Okay. Wait, so that means this whole thing is equal to 0 now.
Yeah.
Is that the answer?
Yeah. I think
We've been on this whole journey for 0.
That's the last term. So when we want the third degree Taylor polynomial, you want all of the terms leading up to it as well.
Oh, right. Okay. So we're looking for for negative cosine, which that's going to be 1 over 2. I'm kind of doing this backwards now. And then negative sine, that's also going to end up being 0. And this is going to be 1 over 1 factorial.
Mm-hmm. So 1 minus a half.
You dropped an x squared in your 1 over 2 factorial term.
1 over 2 factorial. Oh, wait, where's the x squared supposed to be?
Do you have the general form for a Taylor polynomial sort of formula thing?
Oh, you mean for the second form is 1/2 times f double prime of 0 x squared